Okay, so now we're going to start looking at converse theorems and postulates. What does that mean? It says, how can you prove parallel lines if you know that angles are supplementary or congruent? Before, in our notes, if you look back, we knew the lines were parallel. So we were proving just regular theorems and postulates. Now we're going to be proving the converse, which means that if corresponding angles are congruent or if they're supplementary, then the two lines cut by a transversal are parallel. So let's look at the first one. The converse of corresponding angles postulate. If corresponding angles are congruent, then the two lines cut by a transversal are parallel. It's the opposite of what we were proving before. So if this one and this one are corresponding angles, then R and S are parallel. Let's also look at the converse of alternate interior angles. This is the opposite of the alternate interior angles theorem. It says if alternate interior angles are congruent, then the lines cut by a transversal are parallel. So if 4 and 6 are alternate interior angles, if they're congruent, then the two lines are parallel. Converse of alternate exterior angles theorem. If your alternate exterior angles are congruent, then the lines are parallel. Continuing on, the converse of same side interior angles are supplementary, then the two lines are parallel. So same side interior would be like 4 and 5. The converse of same side exterior angles theorem. If same side exterior angles are supplementary, then your parallel lines are parallel. Then the two lines cut by a transversal are parallel. So this is using the opposite information and proving that the lines are parallel. Instead of knowing that the lines are parallel and proving that the angles have a relationship, now we're taking the angle relationship and proving that the lines are parallel. So look at the back. So proving our converse. So if you look, our given angle 1 is congruent to angle 7. So my statement, my first one, angle 1 is congruent to angle 7. Statements go on the left, reasons on the right. This is my given, and I'm trying to prove that line R is parallel to line S. Okay, so you start with those three things. You know where those go. So if I'm going to prove, if I'm given that angle 1 is congruent to angle 7, well, what else do we know? How can I relate back to those two? Well, I know that angle 5 is congruent to angle 7 due to the vertical angles theorem. Well, how can I relate 5 back to 1? Well, what are 1 and 5? Well, 1 and 5 are congruent because of the transitive property Well, how do we know that they're congruent? Because angle 1 and angle 5 are corresponding angles. Why are they? Because the definition of corresponding angles. So you started with what they gave you, angle 1 and angle 7. Then you see how 7 is related to the vertical angle. We've proven the vertical angles theorem, so we know that 5 and 7 are congruent. Then we can say that 1 and 5 are congruent because of the transitive property. Because like here, A is equal to B, C is equal to B, therefore A is equal to B. That's the transitive property. Some of you kind of remember that. A is equal to B, C is equal to B. I might have said that incorrectly. A is equal to C. That's your transitive property. Well, once you have that stated, once you know that they're congruent, then you relate back to, well, they're corresponding angles because of the definition of corresponding angles. So if you've related 1 and 5 to being corresponding angles, you can say that R is parallel to S because of the converse of corresponding angles postulate. So you'll use the information that they give you about the angles to prove that the lines are parallel. Your final reason should end up being a converse postulate or theorem.